Hey everybody, the file that I have open here is the exploring slope and y-intercept that you could find on Blackboard. And this is going along with section 10, the last section, which is interpreting formulas. So we're going to see how everything we learned about slope and about the equations ties in to the formula for a linear. So if you take a look over here, the formula that we're working with is y equals 1x plus 5. So this is the formula that we're working with, okay? And I can even write it up here so this way we don't lose track. So we're talking about y equals 1x plus 5. Okay? So let's focus in on this section of the table that's being generated. How are they generating that table? Well, this part is review. They're plugging in these x values into the function for x, and then they're calculating the corresponding y value. And so if I wanted to show you where this 3 came from, what they're doing is they're plugging in -2. So the work that they're doing is y equals 1 parentheses -2, because they're plugging in -2, plus 5. And then they're working it out. So this is -2 plus 5, and that's where they're getting an output of 3. And then they're doing that for all these other inputs. Okay, so you can verify that on your own if you want. So now let's come over here and look at the graph that gets created from this table. So if you notice, these are all the same ordered pairs. This is -2, 3, this is -1, 4. So this is the graph from this table, from this equation. And we know how to generate all of these things from previous lessons. But now let's put it together with slope. Look at how you would be asked to walk this line. If you went from the left to the right, how would you get from point to point? You'd be going up 1 and to the right 1, and up 1 and to the right 1, and up 1 and to the right 1. And you would continue doing that all the way up the line. So that tells us that our slope, or our rise over run, is going to be up 1 and to the right 1, which just comes out to be 1. Do you see a 1 anywhere in the formula? This 1 is the same thing as that coefficient on x. Let's see if that changes, or how that changes when we change it over here. So let's clear this stuff out, and let's try a different coefficient on x. So maybe I want to see what happens when the coefficient is -2. Okay, interesting. Look at what happened to the line. Look what happened to the formula, or to the table. The formula that we're working with, again, just to remind us, I'll write it up here, is y equals -2x plus 5 now. The way they're generating this table is everywhere there's an x, they're plugging in these x values, and then they're calculating to figure out what the y value is. And then they're plotting these ordered pairs over here on the graph, okay? But now let's analyze how we would walk this line. To walk this line, I would be going down 2 and to the right 1, down 2 and to the right 1, down 2 to the right 1, and that pattern would continue. So if I did my slope, again, looking at rise over run, I would be going down 2, so -2, and to the right 1, which is just -2. Where else do I see a -2 in the formula? I see a -2 right here as the coefficient on x. That tells me that that is my rate of change. That is my slope. Is going to be whatever is being multiplied by x. Let's try it one more time. Let's change this value to be a fraction. Let's change it to be 1/2. Okay, take a look at what happened over here in the table. If you remember, we had said that the cleanest way to work with a fraction coefficient is to choose values for x that are multiples of the denominator. In this case, it's going to be much easier if I plug in even numbers because I know I'm going to be dividing by 2. So take a look at the table. For all even numbers, I got a nice answer. If I plug in -4, I'm going to get 3. If I plug in -2, I'm going to get 4. Okay, and you can see that the even numbers are giving nice whole answers, and the odd numbers are giving fractions or decimals. So it would pay to plug in even numbers here, but I wanted to show you that it doesn't matter. You can still plug in any numbers you want. Just know that you're going to get a decimal or a fraction. So now these values are plotted over here on the graph, and let's see how we would walk this line. I would be walking up 1/2 and to the right 1, up 1/2 and to the right 1. Okay, those are little tiny steps, and I would have to approximate 1/2 because that's not a complete step. However, could I also go up 1 and to the right 2, up 1 to the right 2, up 1 to the right 2? Okay, that works also. So my slope is going to be, if I look at rise over run, up 1 and to the right 2, or 0.5, or 0.5 over 1. All of those are the same thing. The only thing is that we don't like mixing decimals and fractions. It's much nicer to just move in the original fraction, up 1 and to the right 2. And look at that. That is the coefficient on x. So far, I hope you're buying into the fact that this coefficient on x, that is your rate of change. That's how the line is moving, okay? That's your movement on the line. That's your slope. Okay, hopefully everybody buys into slope. Now, let's go back and change this back to 1. And now let's focus on b, okay? So in the beginning, b was 5, okay? And over here, when x is 0, y is 5. Because where else do we see 5? 5 happens to be the y-intercept. I wonder if that's a coincidence. Let's try changing this to something else. Let's see what happens when b is 3. Okay, it shifted down so that my y-intercept is 3. Slope stayed exactly the same. Slope is 1 because I didn't change this value. So that tells me that this must be connected to my y-intercept. Let's try it one more time. Let's change this to -4. Slope stayed the same, but my y-intercept came down to -4. Why is that happening? That's because anytime we plug 0 in for x, this whole term is going to disappear, and I'm going to be left with whatever this number is. So this constant is always going to be our y-intercept. So we just discovered that two features of a line are the slope and the y-intercepts. And we just put together this concept of y equals mx plus b. If you have your equations solved for y like this, the coefficient on x is always slope, and the b is always the y-intercept, or in other words, 0, b. So now we've put all the pieces together, okay? One last thing to tie it all in. We talked about rate of change from our table as well. We looked to see how x is changing and how y is changing. Let's do that over here. My x's are changing by 1s, and my y's are decreasing, they're increasing, by 1s. If I do slope as y2 minus y1 over x2 minus x1, the change in y is 1, the change in x is 1, and so I get a slope of 1. So it doesn't matter whether you have the graph, whether you have the table, you can still figure out the important pieces of the function, which is the slope and the y-intercept. So I hope this video made sense. You can always ask questions about it when we meet. And I hope you're all staying healthy. Take care.